How's it going, guys? It is Tuesday, April 21st. So what we've done so far with 10.2 were examples 1 and 2 from 10.2 lesson. We did examples 1 and 2. You guys just did an IXL benchmark yesterday, and you did pretty well. Everybody did pretty well. So we are going to move on to the second part of 10.2. Where we're going to talk about examples 3 and 4. Okay, so just to point something out, we still have the same learning target. We still have the same learning target that I can solve a square root equation by isolating the square root expression and squaring both sides. Still the same learning target. All right, we're just going to talk about problems that look a little different today. All right, so here's the deal. Example 3 is going to relate very closely to what you will be graded on in another IXL benchmark tomorrow. And then example 4 is identifying something called an extraneous solution, which is something you won't be tested or like quizzed or tested on, but your high school teachers will appreciate the fact that you learned it at least. So we will look at that as well. All right, but mainly we want to focus on example 3 and being able to solve an equation with square roots on both sides of the equation. All right, so let's take a look at that example and see what that means, what that looks like. All right, so if we want to solve, again, an equation where we have square roots on both sides of the equation, here's the deal, guys. We're just going to simply square both sides, and those square root symbols are going to disappear. Okay, so essentially, they really don't really mean anything. Okay, so again, since everything is isolated, there's nothing other than the square root symbol or square root expression on both sides of the equation. Right away, we can square both sides. Okay, right away we can square both sides to get rid of those square root symbols. All right, which is going to leave us with, this is supposed to be 2x minus 1. Let's write that in there because the book looks like they made a mistake here. So this is supposed to be 2x minus 1. All right, so again, we're going to square both sides, okay, just to basically get rid of the square root symbols to leave us with 2x minus 1 over here and x plus 4 over here. All right, we're going to subtract, they subtracted x from both sides first. All right, so like I kind of only said in class, I always like to move my variable first, and the book did the same. So they're subtracting x from this side and this side. So 2x minus x, that leaves us with just x minus 1 on the left equals 4. All right, and then we're going to add 1 to the other side to just get our answer of x equals 5. All right, so that's our solution there. Pretty simple. If you can solve equations with variables on both sides, this shouldn't be difficult, okay, which we learned back in chapter 1. So let's look at an extra example quick for this skill. All right, so again, I'm simply going to go ahead and I'm going to square both sides right off the bat because all I have are two expressions underneath square root symbols, okay? That's simply going to leave me 2x plus 2 equals 3x minus 7. All right, I just was saying I always like to move, I'm going to put a line here, I always like to move my variable first. So I'm going to subtract 2x from both sides. Sorry that this is sloppy, it's really hard. That leaves me 2 over here equals 3x minus 2x gives me just x minus 7. All right, and if I want to solve completely now, I want to isolate x, I'm going to add 7 to both sides, add 7, which is going to give me x equals 9. All right. As always, you can kind of go back and check your solution, plug it in, and you should be good to go. These should end up being equal to each other. Okay. So again, if you can solve equations with variables on both sides, which you should be able to, this shouldn't be too hard. All right. Let's have you guys give it a shot quick. So here are two examples where you can try it. I am going to have you pause your video at this time, give these two problems a shot, and then when you come back, your answers will be up. Okay, so x equals 8 and x equals 1/4 for our answers here. Hopefully that makes sense. Let's move on to what I said. You won't really be quizzed or tested on this skill, but it's nice to know. High school teachers will appreciate it. All right, so example 4 is identifying an extraneous solution. So what in the world does that mean? So here it says, squaring each side of an equation can sometimes introduce a solution that is not a solution of the original equation. This solution is called an extraneous solution. Be sure to always substitute your solutions into the original equation to check for extraneous solutions. So what's going to happen here in this example is when we square both sides, we're going to end up with a trinomial. Okay, we're going to move everything to one side and we're going to end up with a trinomial that we're going to factor. And we're going to end up with two solutions. And sometimes those two solutions can be plugged back in and make the equation true. And other times one solution doesn't make it true. It makes it false, the equation. All right, so that's what they mean. So in this example, what we need to do is we need to solve it first by, you're going to see, we're going to have to factor. And then you guys are going to have to go back and plug in the solutions you find to make sure that there's not an extraneous solution. Because again, sometimes one number gets plugged back in and it makes the equation false. Okay, so let's see what I'm talking about here. All right, so since I have an expression underneath the square root symbol isolated, I am right away going to square both sides. Now you're going to see what happens here. So I'm left with x squared equals x plus 6. When I have this, when I have x squared, I can't really solve by subtracting x because these aren't like terms, right? So what I need to do is I need to picture this as I need to factor it, so I need to make everything move to one side. All right, so remember, I always want my first term, my x squared term, to be positive. So what they did was they moved the x by subtracting it, and they moved the 6 by subtracting it to make a trinomial. Okay, so hopefully you know where to go from here. When I have a trinomial like this, here's what I want to do. I want to factor it, all right? Still using skills from chapter 7. Sorry. So I want to figure out what multiplies to -6 and adds to -1. Those numbers would be -3 and +2. Okay, so if you know this step, I'm going to move on and show you what the book does. All right, so what do they do? At that point, they write two binomials with these factors. Okay, so x minus 3, x plus 2 equals 0. Remember, to solve now, we want to figure out what makes each expression equal 0. Okay, so they set each expression equal to 0 and solve them both. All right, so we end up with x equals 3 or x equals -2. Now, when there's two solutions in these types of problems, you have to go back and plug these numbers into the original equation to see if there's an extraneous solution. So sometimes both numbers, when plugged back in, they work, all right? They make the equation true. But other times, if we look here, 3, when we plug 3 in, it does make the equation true, all right? But when we plug in -2, when we plug in -2 to the original equation, I end up with -2 equals the square root of 4, and the square root of 4 should be +2. So -2 does not equal +2. So it says now, because x equals -2 does not check in the original equation, it is an extraneous solution. So the only solution that makes sense is x equals 3. Okay, so that's what we mean by an extraneous solution. Sometimes one of the numbers, when plugged back in, doesn't work. It doesn't make the equation true. Okay, let's look at this. All right, let's try this. Same concept. I see an expression underneath the square root symbol by itself. I'm going to square. I'm going to square both sides right away. All right, I'm going to move up here. So I'm going to have x squared. And bear with me, this is hard. You know what I'm going to do right away? I'm going to subtract the x, because basically what's going to happen here, the square root symbol just goes away, okay? And I'm going to move everything to this side. So I'm going to subtract the x, so minus x, and I'm going to subtract the 20, okay, to get my trinomial. Get it set equal to 0. Why? So that we can factor it. Okay, so at this time, sorry, again, this is really difficult. I have negative 20 on the top and then just negative 1 on the bottom. What are my numbers? Negative 5, and positive 4 should be the numbers that would work. Okay, so I'm going to go ahead and make my two binomials. Trying to see what makes each expression equal 0. So 5 for this one, or negative 4 for this one. So as always, it's always the opposite of my factors, right? My solutions. Okay, so now I got to check it. All right, so I want to see if there's an extraneous solution here. All right, so I'm going to erase all this work down here because I'm just going to use the original equation I had. Okay, so let's try plugging in 5 for x first and see if that works. Okay, I would have 5 equals the square root of 5 plus 20. So the square root of 25. The square root of 25 is 5, so this works. Okay, this works. Now let's try the other one. All right, so let's plug in negative 4 and see if that works. So negative 4 equals negative 4 plus 20, so the square root of 16. The square root of 16 is positive 4, so I end up with this. I end up with negative 4 equals positive 4, and that's not true. Okay, so negative 4 would be my extraneous solution. Okay, so this really doesn't work, and only 5 does work, so that's my only solution here. Okay, like I said, there are examples, which you're going to see in big ideas, the assignment you're about to do, where you plug both numbers in and they both work. Okay, but then there's other times that, as you can see here, 5 worked, negative 4 did not. Okay, it makes the equation false. So hopefully that made sense. Now you guys are going to go into big ideas, all right? And you have a 6-question practice, all right? It's called 10.2 practice. It's part 2 because that was part 2 of our lesson, and that's going to wrap up 10.2. All right, so you're just practicing today those 2 types of problems that I just taught you, and then tomorrow you will be doing IXL, and you will be doing, I believe it's FF.5. So yep, so it's solving radical equations 2, and it's just like example 3. Okay, it's just like example 3. So that's what you will be, you'll be given a benchmark on that. But again, today's lesson or today's practice is only practice. It's not graded. Okay, so again, hopefully this all made sense. As always, if not, email me or leave questions in the discussion thread on Canvas, and I'll talk to you guys tomorrow.